So our next speaker is my friend and colleague, Richard Seager, who's also from Columbia University. He's a research professor at Lamont. He's one of the leading authorities on the impact of climate change on drought at continent scale. And if any of you have heard of this story that was in the news many years ago about how the West is entering an imminent drought that's progressive, a trend that's leading throughout the remainder of our lives. This actually was Richard's contribution to this. So it's a great angle from a great continuation of where Wolfram took off. So Richard, I think you guys, you're all fine.
Yeah, that should be okay. All right, thanks very much, Peter. And Wolfram set this up very nicely, and I'll skip through some of the early stuff in order to follow on directly from what he said. So I'm going to talk about climate and mostly agriculture, but a little bit about water more generally. And according to the US Department of Agriculture, still as of today, climate change is real. Maybe this website will vanish later this week or something. But that I will skip through in order to move on. So the first thing I do just briefly want to say is that when it comes to climate change and water, climate variability and change in water, it's not just a case of agriculture, but we've had in the last 2 years two very high-profile cases where massive cities in the world are suffering serious problems with the water supply. One of which is Mexico City. You probably saw the stories in that. In the New York Times recently. There isn't necessarily that much of a climate component of water shortage there right now, but Mexico is one part of the world where we are quite confident because of warming temperatures and changing precipitation, the water supply from the atmosphere is going to become less reliable. And in Mexico City, as they've been trying to get more water from their hinterlands, they've run up the trouble against, in this case, these are indigenous people who are upset with Mexico City trying to take some of their land and use it for water supply. And then the other one that occurred very recently was Sao Paulo, which is the largest city in the Western Hemisphere, in Brazil. And they had a multi-year drought that seems to actually have, according to workers at Lamont, seems to have been the Southern Hemisphere equivalent of the California drought. They were both being driven by sea surface temperature anomalies in the tropical West Pacific that may be purely natural variability, but also look to have possibly some climate change component in both setting off wave trains in the atmosphere that created ridges of high pressure and dry conditions both in California and in Sao Paulo. In Sao Paulo, there's extensive mismanagement of the water resources, not so in California, but there is there. And Sao Paulo, the people were having major drops in water supply there. So we can come up with many other examples around the world of these urban water supply issues. They have both humanitarian consequences, they have health consequences, they also have economic consequences as well. But moving on towards the agriculture, this is just some maps of how models project hydroclimate will change in the future. The one at the top left there is precipitation, red, dry, blue, wet. So you do actually see that the models predict many regions will actually get wetter in terms of more precipitation. But you see these bands of red in subtropical regions, especially around the Mediterranean, Southern Africa, Southwest North America. But that's not the only thing that matters. As the atmosphere warms up, it holds more moisture, it takes more water out of the surface. So there's a demand side to the surface water supply as well. And that's measured by the top right, which is potential evapotranspiration. So the ability of the atmosphere to take moisture out of the surface just goes up everywhere. And when you combine these into various indices of droughts, like the amount of soil moisture in the soil, you see widespread drying in many, many, many parts of the world, with some hot spots in Southwest North America, the Mediterranean, Middle East, Southern Africa, and so on. So many of these places are at risk of having drops in water supply that will both be a problem for urban society and also for agriculture. And this then really follows on directly from what Wolfram was doing. Here we've taken all of the climate models that were done as part of the last IPCC report. We have about 70-something different simulations done with these, with 40 different models. And we've looked at summer growing temperatures in a number of major grain-producing areas. So this is the Corn Belt of the United States. And the top picture here just shows you the rise in the temperature. Red is the median of the models, and the up and 25th and 75th percentiles of the green and the purple, and that goes out from 1980 to 2100. So you see the mean temperature rising. Those colours is precipitation minus evapotranspiration. Not so much of a trend in that, but this rising temperature. And then the middle picture, we're actually looking at the maximum temperatures. At the bottom picture, sorry, we're looking at the maximum temperatures that occur in a month. So daily maximum temperatures during the growing season. And this is in 2-decade periods out to the end of the century. And the box, don't forget the details, it shows the scatter. But you can just see how much these are increasing relative to the end of the 20th century. We're seeing increases of more than 5 degrees centigrade by the time we're getting towards the end of the century. By the middle of the century, it's already dangerously high. So these, in Europe, the temperature rise, and this is consistent with Wolfram's plot, seems to be even rise, even higher than in the Corn Belt. And you also see that the maximum temperatures are increasing more by the mean temperatures. So, and then moving on to, this is also a place where summers apparently get drier as well in Europe. So this is France, Germany, Poland, Ukraine, Russia, the main wheat, corn producing areas of Europe. And then in China, eastern China, a big wheat producing area, you've got this same temperature rise, it does get slightly wetter there. And then in Southeast South America, which in recent decades has become a major supplier to the global grain trade, again, we're seeing a big increase in temperatures. The variability in temperature is rising as well. So you're just seeing in all of these areas, you're just seeing ever more threat from brutally hot growing seasons that are almost certainly going to be leading to shocks to the supply. Europe seems to actually be particularly worrisome scenario. Now, because we have a global trade system, these shocks are not going to be localized. They immediately get felt around the world. And this is some work by some other people where they actually looked at trade deficits, but from the caloric point of view, in order to identify those countries in the world that one, eat a lot of one particular grain and also import a lot of that grain. And they blew up the Middle East here. Egypt is one example where most of the large quantity of the calories consumed by the population is wheat. They do not grow much of that wheat themselves. Much of it is imported from Europe and other Middle Eastern countries, from Canada, the United States. So a climate shock in the Midwest or in the Ukraine immediately gets felt around the world and ends up in a price shock, with countries like this being extremely vulnerable to those. And then other workers have looked at this and tried to find out whether there's then a connection between food price shocks and social unrest. And they did this using social media reportings on anything that was like food riots or protests about food prices or bread availability and so on. And you see that with the two recent shocks that occurred in the last decade, this is the wheat price index in red, the maize and corn, the maize and soy price index has had those spikes too. And then the curve down here is the incidences of social unrest that occurred, and you just see that the price rises immediately feed into social unrest. Of course, some of these were events that we're living with the effects today because they were in the Arab world. And one case of a slightly different case is Syria, where the climate shock and the crop production shock was operated more locally. So in the latter part of the last decade, Syria experienced a multi-year drought that we wrote about in a paper that was the worst in the instrumental record. It lasted for several years and led to a large migration of farming families from northern Syria to cities in Syria that were already overcrowded because of the 1.5 million refugees that had fled to Syria from the civil war in Iraq. But it contributed to the trouble that Syrian society was having before the onset of the all-out civil war. At the time when we wrote that paper, we just had the instrumental rain gauge data, but since then, working with colleagues at Lamont and across Europe, we've developed a tree ring-based climate history of all of Europe and the Middle East and North Africa that goes back 1,000 years. And when one of our colleagues, Ben Cook, published a paper about that recently, he was able to show that not only was that the worst drought in the instrumental record, this was the worst drought that had occurred in the Levant, in Syria, in 1,000 years. And that is very, very consistent with what we expect for climate change in that region, that because of changes in atmospheric circulation primarily, North Africa, southern Mediterranean, the entire Middle East are going to become less winter precipitation, hotter and more arid. And this kind of rapid change here that we're seeing from the tree ring data is consistent with that signal in climate change already occurring. So that's just the story I said about Syria. So climate change will exert increasing stress in major rain-producing regions synchronously, I think, because of a combination of natural variability and climate change. So as Wolfram said, right now in climate variability, it tends to do different things in different parts of the world. It might be wet in some places and dry in others, and the global grain yield might not be affected so much by that. But that needn't be the case as we go forward in the future, and some regions are consistently being stressed in terms of crop production because of warming and or drying. But what we need to work out is how that variability plus change will evolve in the coming decades, and especially what the odds are for bad harvests in multiple grain baskets at one time, so that you do start seeing volatility in the total global supply. And some of this is actually predictable. This is some work that a student of mine is developing into his PhD thesis. And what we've done here, we've done this for maize, wheat, and soy. So this relates to the El Nino Southern Oscillation. You have this endless sequence of warm conditions in the tropical Pacific, El Ninos, and cold waters, La Ninas, and they tend to progress. And what we've done here is look at Pan-America, so it's the total amount of production of maize and wheat across the Americas going through El Nino and La Nina life cycles. So you can actually, La Nina it goes down, in El Nino it goes up, one of those follows the other. So you can actually develop some multi-year anticipation of what will be happening. We're now extending this out to the other side of the Pacific in Asia as well, to begin getting global life cycles. So I'll just leave the conclusions there since my time is up. Thank you.